Okay, it asks us to identify which of these triangles is congruent. So again, triangles or any figures are congruent if their corresponding parts are congruent. So if their corresponding sides are congruent and their corresponding angles are congruent, then the figures are going to be congruent. Okay, so the way we're going to do this here is you could find the lengths of all the sides of these triangles. We could use the distance formula to find the distance between B and C and A and B, and then use the distance formula here, but that's going to take quite a while. But the basic idea here is if we're going from B to C, we're going up 1 and over 3. So we need to look for on the other triangles if there's a place where we're going up 1 and over 3. Then they'll be the same distance. So if we look from K to L, you're going up 1 and over 3. So it looks like B is going to match up with K here, and C could match up with L. If you go over to this one, we're going up 2 and over 3. So it doesn't look like these two triangles, right? BC is not going to be the same length as FG. But it is going to be the same length as LK, so we can check the other ones then. So from A to B, we're going up 4 and over 1. Okay, and if we look at E to K, they're going up 4 over 1. So it looks like EK is going to be congruent to AB. We could match these up here. Right, and again, there's no over on this one. It's just up 4, so that one's not going to work. And then AC here, 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5 up. 1, 2, 3, 4 to the left, and then 1, 2, 3, 4, 5 up. So we're going over 4, up 5, over 4, up 5. So that means AC, the length of AC is going to be the same as the length of LJ. Okay, and you can, if you want to verify that, use the distance formula, right? And you can find the actual lengths of those segments. Okay, but I don't think we need to do all of that. Okay, so triangle. Okay, let's name these triangles then that are congruent. Okay, so if we name the first triangle here, there's 6 different ways we can name it: ABC, CBA, BAC, BCA. Right? ABC, BCA, CAB, and then the other way: BAC, ACB, and CBA. Okay, so 6 different ways there. Let's just name it ABC. Okay, it's the same triangle. Okay, but then we have to match up our corresponding parts. So we have to go to the other triangle and say in A, in the other triangle, what matches up with A? That's going to be J down here. B is going to match up with K. And then C matches up with L. Okay, if we name the first one a different way, let's just say we named it BCA. Okay, we would just have to shift the letters around. So B is going to match up with K here. Right, C is going to match up with L. And then A matches up with J. Oops, J. Okay, so BCA would be, and again, you could name it 4 different ways to name this. The idea is you can name the first one however you want, but the second one, you're going to have to match it up with the corresponding vertices. Okay, so those 2 triangles are congruent. If you look at the triads, they also ask for you to give the composition transformation. So let's do that here. So for this one, since it's reflected around the other way, I would do a reflection over the line x equals -5. Right, so if we reflect B over there, it's 3 to the left. We need to go 3 to the right. A is 1, 2, 3, 4 to the left. We need to go 1, 2, 3, 4 to the right. So if we reflect it over, it's going to look like this. Okay, so we're reflecting over the line x equals -5. Okay, and then we're taking that reflection, right? So we're reflecting ABC if we write it out formally. Triangle ABC. Okay, we're reflecting that over line x equals the line x equals -5. And then we're simply going to translate that. We can translate that 1, 2 to the right, and 1, 2, 3 down. So 2 to the right, 3 down, 2 to the right, 3 down. So if we translate that 2 to the right, that's going to be positive 2, and then negative 3. So we're taking the translation of the reflection over that line of triangle ABC, and that's going to give us triangle JKL. Okay, and again, many different ways to do that. You could have rotated it. Well, actually, I'm not sure rotation would work here. But you want to do reflection, then translation works fine. But again, many different ways to have done that. Okay, and if you go through theirs, see they shifted it down, and then they reflected over that line there. X equals negative 4. So theirs looks a little different. Right, theirs would be the reflection. I'm sorry, theirs would be translation down. So if we wanted to write theirs out. Right, so they have, first thing they did was a translation. 3 down, so 0, negative 3. Right, of triangle ABC. Right, they translated triangle ABC down 3, and they took that translation and reflected over the line x equals negative 4, right, and that got them triangle JKL. So numerous ways to do this.